This is a GCE O-Level Pure Physics revision series. In this video, we will discuss multiple choice questions that you must know before you take your examination. The questions discussed here are related to Chapter 3, Dynamics. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out important updates from us. Also, check out the description area to sign up to our signature course, GCE O-Level Pure Physics Full Course, at unbelievable price. It's one-time payment. You can study anytime you like, anywhere at your convenience. You can also easily monitor and track your study with Udemy's system. There is no recurring monthly tuition fees. No expensive intensive revision workshops. You don't have to rush to any tuition centers. You don't have to worry on missing any lessons. Sign up our signature online course at description area now. Without further ado, let's get started now. Chapter 3, Dynamics. Question 1. When a block of wood of mass 5 kilograms is pushed along a horizontal flat surface, the frictional force is 8 newtons. When it is pushed along the same flat surface with a force of 12 newtons, it moves with a constant A. Acceleration of 1.6 meters per second square. B. Acceleration of 0.8 meters per second square. C. Acceleration of 2.4 meters per second square. D. Acceleration of 4 meters per second square. The answer is B. Acceleration of 0.8 meters per second square. Resultant force, F, equals ma. Resultant force, F, also equals driving force minus frictional force. Hence, ma equals driving force minus frictional force. By substituting the given values into the equation, we get acceleration equals 0.8 meters per second square. Question 2. Toy car X and toy car Y are joined with a stretched spring. Toy car X has twice the mass of toy car Y. When the toy cars are released, toy car X accelerates to the right at 4 meters per second square. What is the acceleration of toy car Y to the left? A. 2 meters per second square. B. 4 meters per second square. C. 6 meters per second square. D. 8 meters per second square. The answer is D. 8 meters per second square. Both the toy cars experience the same tension by the stretched spring. T equals ma. Mx a x equals my a y. Given that m equals 2my. Hence 2my times 4 equals my a y. My is cancelled in both sides. Hence, acceleration for toy car Y is 8 meters per second square. Question 3. The diagram shows the wheel of a car accelerating to the left. In which direction is the frictional force acting on the wheel? A. Towards A. B. Towards B. C. Towards C. D. Towards D. The answer is D. Towards D. The force towards A is a normal force reacted by the road surface to the weight of the wheel. The force towards B is the driving force by the wheel to push the car to accelerate to the left. The force towards C is the weight of the wheel acting on the road surface. Frictional force is always in the opposite direction of driving force. Question 4. A car of mass 500 kilograms is moving along a level road. The driving force of the car is 3,600 newtons, and the total resistive force is 2,000 newtons. Calculate the acceleration of the car. A. 1.6 meters per second square. B. 3.2 meters per second square. C. 6.4 meters per second square. D. 4.0 meters per second square. The answer is
B. 3.2 meters per second square. Resultant force, F, equals M. A. Resultant force, F, also equals driving force minus frictional force.
hence M equals driving force minus frictional force. Substitute the given values into the equation. The result that we get is 3.2 meters per second square. Question 5. A heavy box of 6 kilograms is being pulled along a rough surface by a force of 54 newtons. If it accelerates at 3 meters per second square, what is the frictional force, F?
A. 9 newtons. B. 18 newtons. C. 36 newtons. D. 54 newtons.
The answer is
C. 36 newtons.
resultant force, F is driving force minus frictional force. Hence, frictional force equals driving force minus resultant force. Substitute the values given, and the result is 36 newtons. Question 6. An aeroplane is taking off from an airport. It is climbing up to a greater height, gaining speed. The 4 forces acting on it are as below. L is the lifting force from the wing. W is the weight. T is the thrusting force by the engine. R is the air resistance. Which statement below is correct?
A. L is equal to W.
T is equal to R.
B. L is greater than W.
T is greater than R.
C. L is equal to W.
T is greater than R.
D. L is greater than W.
T is equal to R. The answer is
B. L is greater than W.
T is greater than R. Since it is climbing up, L is greater than W. Since it is gaining speed, or accelerates, T is greater than R. Question 7. What is the resultant force of the forces acting at point O as shown in the diagram? A. Magnitude equals is 15 newtons. Direction is OQ. B. Magnitude equals 15 newtons. Direction is RP. C. Magnitude equals 21 newtons. Direction is OQ. D. Magnitude equals 21 newtons. Direction is RP. The answer is A. Magnitude equals 15 newtons. Direction is OQ. By Pythagoras' theorem, the magnitude is square root of 9 squared plus 12 squared. The result is 15 newtons. Direction is the diagonal line OQ. Question 8. A heavy mass of 20 kilograms is being pulled by a worker with a pulley and is suspended as shown in the diagram. What is the resultant force acting on the mass?
A. 20 newtons. B. 100 newtons. C. 200 newtons. D. 0 newton. The answer is D. 0 newton. Since the mass is motionless, it is experiencing balanced force. Hence resultant force is 0. Question 9. Which of the diagrams above shows the correct vector diagram, where P and Q are the forces acting on a mass, and R is the resultant force? A. Diagram A. B. Diagram B. C. Diagram C. D. Diagram D. The answer is C. Diagram C. Using tip-to-tail method, the resultant force, R, should be as shown in this diagram. Question 10. A bowling ball and a piece of paper is released at rest from a tall building. Which of the following statements is true? A. Both of the objects will land on the ground at the same time. B. Both of the objects will have different initial accelerations. C. Both of the objects will have the same speed when they touch the ground. D. The bowling ball will land on the ground first.
The answer is
D. The bowling ball will land on the ground first.
Since the bowling ball has greater mass than the piece of paper, it takes longer time to achieve terminal velocity. Hence it will have greater terminal velocity and land on the ground first. That's all for this video. Thanks for watching. Do you have any thoughts, opinion or experience want to share? Write it down in the comment area. We'd love to hear from you. Also, do you like this video? Don't forget to like and share it to your friends. Until then, see you in the next video. Have a great day ahead.